How do I copy? Mm. Please put it where I want it. Yeah, just try to sit towards the back so that it doesn't disturb everybody, is all I usually ask. Come on. Be nice. Give me. I don't know what else to do. That's okay. No. Slip off. No. I'll just write it on the board. Okay.
Well, no. Okay, so the first thing I wanted to do is figure out what I did with it. I'm going to go over what's going to be on your test Friday. Okay. First of all, there is a table that you have to complete regarding each of the subatomic particles. You got to know the charge, you got to know where it's found, you got to know what it's responsible for. There are two problems that you will be required to determine the average atomic mass, which is what we're going over today. There is a problem where you're given isotope symbols, generic isotope symbols, and you're asked which ones are isotopes. And basically you need to know the appropriate terminology. You need to know the terms mass number and atomic number and what they mean. And then you need to be able to determine what the isotope is given the mass number and atomic numbers for those generic isotopes. This test looks long because several pages have only two problems because periodic tables take up a lot of space. The next question, you will either be asked to highlight the metals, metalloids, or non-metals. There are two questions that require you to know the special group names. So I could ask for the alkali metals. I could ask for the alkaline earth metals. I could ask for the halogens, or I could ask for the noble gases. There are two questions that require you to understand period and group. Actually, no, there are three questions that require you to know period and group. There is a question that requires you to know the difference between main group elements and transition metals. With the periodic tables, make sure you read, because sometimes I ask you to highlight or shade in areas. Sometimes I ask you to give me the elemental symbol for the information. So make sure you read. There is a problem with 5 parts that is similar to what we were doing on Friday, where you have to give me the protons, neutrons, electrons, atomic number, mass number, isotope symbol. There are 2 additional columns to that table though. And that is, you have to give me the element name and the element symbol. There is one question where you use density as a conversion factor. And there is one question where you calculate the density. I do not give you the formula for density. I do not give you the formula to calculate mass number. But I do give you the formula to calculate average atomic mass. And I do give you your periodic table. That is the test. Any questions? Unlike the last test, you need to be, you will not get a second chance if you make a mistake on this one. I will say you have about 5 times longer than it took me to take the test. And that's because I don't have to look at anything. I can just rattle off stuff. So you should have plenty of time to take this test. Any questions? Okay. I'm going to write up some information on the board just so that I have it readily available. And then we will get started into today's information. We're going to need that information for what we're starting, where we're starting today. Okay. So the first thing we're going to do today is we're going to determine the atomic mass for an atom of an isotope. The second thing we will do is we will determine the average atomic mass of an element. So let's start with the atomic mass of an atom of an isotope. And to illustrate this, let's look at oxygen 18. From Friday's information, if I asked you to give me the number of protons, number of electrons, and number of neutrons, what would be your answer? Huh? 18, yes. Sorry. Let me make it more clear. I'll use the bigger version. Okay. It is 10 neutrons. Why did you say it's 10 neutrons? Because atomic number is 8. That means it had 8 protons and 8 electrons. Okay. Now, we know that there are 8 protons and each proton has a mass of 1.0073. So the protons are contributing 8.058. Ooh, that looked terrible. 8.0584 to the overall mass. We know that there's 8 electrons, and the electron has a mass, each electron has a mass of 0.005. Therefore, the electrons contribute 0.004 to the overall mass. And then there are 10 neutrons, which each contribute 1.0087. So it has a mass of 10.087 from the neutrons. All of these make up the atom of the element. So if we were to add them together, we get a value of 18.1494 atomic mass units. This is the mass of one atom of isotope 018. Questions? Let's look at another example. Let's look at fluorine 19. If I have fluorine 19, what do I know about the protons? There are 9 because it is fluorine, meaning there's also 9 electrons. So how many neutrons must there be? 10, because the number of protons plus the number of neutrons equals the equals the mass number. Proton has a mass of 1.0073, electrons 0.0005, and neutrons 1.0087. So looking at this, the protons contribute 9.0657. The electrons contribute 0.0045, and the neutrons contribute 10.087. When you add those together, you find that it has a mass of 19.1572 atomic mass units. Why does this make sense? Because every single proton has its own mass. Well, if there's 9 protons and each proton has its own mass of 1.0073, that means that all 9 combined contribute the 9.0657. If it has 9 electrons and each electron is 0.0005, then 9 electrons combined is 0.0045. And if you have 10 neutrons and each neutron comes in at 1.0087, that means that the neutrons contribute 10.087 total. So when we add all the protons and all the neutrons and all the electrons together, you get the mass of an atom of an isotope. Questions? Okay. Now, and by the way, on these average atomic mass calculations I'm about to do, this is the only time I will not count sig figs. Now, the average atomic mass takes into account all naturally occurring isotopes of an element and their abundance. To calculate the average atomic mass, this will be equal to the sum over all naturally occurring isotopes of the isotope mass times the abundance. Again, sigma means sum. Or in other words, addition. This is the equation you're given on the test. To illustrate, let's look at an example. Let's take helium. Let me not do helium. Let's take lithium. Okay. Lithium has two naturally occurring isotopes. It has lithium-6 and lithium-7. Lithium-6 has an isotope mass of 6.01. Ugh, hate it when it does that. 6.0151228874. And that one occurs 7.59% of the time. Lithium-7 has a mass of 7.0160034366 and occurs 92.41% of the time. Folks, I could tell lithium-7 was the most common isotope without even having this information, because if you look at the average atomic mass for lithium, it's closer to 7. So since it's pretty close to 7, that's telling me that it's probably 7 would be the main one. Now, I want to highlight a key piece here. In the equation, I said abundance, not percent abundance. So the first thing I'm going to do is I'm going to take this out of percentage to 0.0759 and 0.9241. I'm then going to multiply the isotope mass by the abundance for both isotopes. So 6.0152288874 times 0.0759 is 0.456556. And 7.0160034366 times 0.9241 is 6.483888. You then add those two together. And you get a value of 6.940048. This is the average atomic mass for lithium. Does it perfectly match up? No, and that's because this is determined, the data I'm using is determined experimentally. And you will be given the experimental data to figure out your average atomic mass. But you can't guarantee it'll match perfectly with that periodic table, because it depends upon where I get the data from. Some data is a little bit more accurate than others. Let's look at another example. Let's look at neon. Neon has 3 isotopes. It has neon 20, neon 21, and neon 22 that are naturally occurring. Neon 20 has a mass of 19.992440. 21 has a mass of 20.993846. And 22 has a mass of 21.991385. Neon 20 occurs 90.48% of the time. Neon 21 occurs at 0.27% of the time. And neon 2 occurs 9.25% of the time. Again, the first thing I do is I take it out of percentage, because it's not percent abundance, it's abundance. So I divide by 100. You then do the multiplication between the mass and the abundance. So it's 19.992440 times 0.9048 is 18.089160. 20.993846 times 0.0027 is 0.0566834. And 21.991385 times 0.0925 is 2.034203. Add those together. And you get a value of 20.18 atomic mass units. Take a moment and look over that and make sure you're confident in how to determine the average atomic mass. Yes. No, I'm not. This is the only time I allow you to get away without sig figs. I mean, technically, yes, I am, but not because I have to.
Like if you were to write it in that form, if you were to get cut off the numbers, would that be right too?
Yes,
Okay.
it would be. Yes.
So are we given like the asterisks and mass?
You will be given the mass and the percent abundance.
Oh, okay. So when you said that you would be getting the mass numbers, how do you mean?
Oh, I know what your question is. I was trying to think back when I said mass number and you won't be given it. You will not be given the equation to calculate the mass number. Mass number is the number of protons plus the number of neutrons.
Oh, okay, so we don't have.
You're not going to be using this on the test.
Okay, I was like.
All I wanted to illustrate with this, with the first two problems I did, is where these. So that's a great, let me explain, actually, because I didn't do that. The reason I did the first two problems in class today is to demonstrate where these numbers come from. Where did the isotope mass of 6.015112 come from? Well, it came from the fact that lithium has 3 protons, 3 neutrons, and 3 electrons. If you add up their masses and you get a lot more specific, then you could get the 6.015. Where did this number of 7.016003 come from? Well, it came from the fact that lithium 7 has 3 protons, 3 electrons, and 4 neutrons. Using a much more specific number than what I gave you here, you would get the atomic mass unit that is illustrated right there for the isotope mass. So the first two problems I did, all I was trying to illustrate is where this isotope mass came from. Comes from the protons, neutrons, and electrons, which we had already talked about. What you have to do, be prepared to do on the test, is determine the average atomic mass given the isotope mass, given the percent abundance for all of the isotopes in an element. So let me give you one to do. We're going to do chlorine. And by the way, be prepared to show your work on this answer, on this question. Be prepared to show your work. Okay, with chlorine. Chlorine has 2 isotopes. It has chlorine 35 and chlorine 37. Chlorine 35 has a mass of 34.968852682. And chlorine 37 has a mass of 36.965,902,602. Chlorine 35 appears 75.76% of the time, whereas chlorine 37 appears 24.24% of the time. Calculate the average atomic mass. Okay, you should have gotten 35.4529375 AMUs. Which, if you're looking at sig figs, would have been 35.45 AMUs. And if you look at the periodic table, it's 35.453 AMUs. So we did, this one calculated out exactly like the periodic table. Questions? Yes.
Would you like us to do the rounding, or do you just want the whole decimal?
The question is, do I want you to do the rounding or the whole decimal? I don't really care.
Okay.
On the test, I will give credit as long as your number is correct for these two problems. I will be paying attention to the work for these two problems. On density, the density questions now have to be to the correct sig figs. So there's two questions that'll be to the correct sig figs, but but it won't be these two questions. Okay, so this concludes where your test ends. Hopefully giving you plenty of time to prepare for your exam. What we are going to begin on Wednesday is probably equally challenging as the mathematics, if not more challenging for some. Because what we're going to begin on Wednesday is we're going to take the atoms of the elements and we are going to talk about how those atoms of elements become ions. They become ions in preparation of making ionic compounds. We're going to spend Wednesday and Monday, at least, talking about all of the ions of the elements and talking about the polyatomic ions. Then we're going to start making compounds with the ions. And we're going to start naming those compounds and figuring out the formulas for those compounds. So that's where we're headed. And then once we finish with ionic compounds, we're going to go to covalent molecules. And we're going to make covalent molecules and learn how to name those and develop the formula. Only once we get through with compounds can we actually start reactions, which will be the last part of the semester. So we're getting there. Okay, I will see you on Wednesday to start ionic compounds.